In this pencast, we'll be talking about finding a common monomial, factor, in a polynomial. And the fancy way, a word for this is called factoring. So when we're trying to find a common monomial, what we need to do is find some monomial that is common in all three terms of our polynomial. And there's a couple of ways we can do this. The easiest way is to start with the constants. And there's two methods we can use to find out what the common constants are. One is we can do the factor tree. So if we take the coefficients of each monomial in the polynomial, so 24, 12, and 18, and we factor them, you see that 24 can factor into 12 times 2, 12 can factor into 6 times 2, and 6 can factor into 3 times 2, and we see that nothing else can be factored. If we move over to 12, we see that 12 is 6 times 2, and then 3 times 2. And 18, we see is 9 times 2, and then 3 times 3. From here, we need to find numbers that are common in all three of the terms, and that's going to be our common constant. So we see that there's 1 3 here, a 3 in the 12, and a 3 in the 18. There's a 2 in the 24, a 2 in the 12, and a 2 in the 18, and there's nothing else in common. That means that our greatest common factor, or GCF, is going to be 3 times 2, or 6. The second method we can use is kind of like an upside-down division. We again start by writing the three constants, so 24, 12, and 18. And then just like synthetic division, we draw the bar underneath the numbers. Now we need to find a number that is common in all three of them. We see that 2 is. How many 2's are there in 24? Well, we know there's 12. How many 2's are there in 12? There's 6. And how many 2's are in 18? There are 9. And then we continue doing this. We see that there's a 3 in common with all three of the terms. There are 4 3's in 12, 2 3's in 6, and 3 3's in 9. Since there's no other terms in common, then we take the terms on the left and multiply them. So again, we get the GCF, or the greatest common factor, is 2 times 3, or 6. So you can see that both methods give you the same answer, so it's up to you with which one you want to do. So now that we know that 6 is the greatest common factor, we can factor the 6 out of the entire polynomial. And we do that by dividing each polynomial, each term of the polynomial, by that number. And then that would look like 6 times, 6 times what gives us 24xy squared? When we know that 6 times 4 gives us 24, and then x and the y squared are the same. We continue doing this. There are 2 6's in 12, and then we write the variables, and there are 3 6's in 18, and then we continue writing the variables. From here, we need to continue looking for common terms. We've already done the constants, so now we can look at the variables. Let's look at x first. In the leftmost term, we have x. In the middle term, we have x squared. And in the third term, we have x cubed. So x cubed, x squared, and x. Among those three things, if we were to factor them, we'd see that we can pull one x out. So we're going to, in these three, we can say we have one x in common. And obviously you don't have to write this down, but you can if it helps you. So if we pull that x out, we have 6 times x. 4 stays the same. The x comes out, so x divided by x is just 1, so it's no longer there. The x squared divided by x is x, and then the y stays. And x cubed divided by x is x squared, and the y stays. Now we can look at the y terms. We have a y squared, a y, and another y. Among all of those three terms, we can have one y in common. And so if we pull that out, we have 6 times x from before, then times y. 4 stays the same. Y squared divided by y is y plus 2x. And the y divided by y is 1. And plus 3x squared. And that should be the end of that. We can clean this up a little bit by multiplying the thing on the left, so it's just 6xy, parenthesis 4y plus 2x plus 3x squared. And we can check our answer by distributing the 6xy over each term and seeing if it gets us the original equation, which in this case it does. So this is our final factored answer.